My name is Etienne. I work for Gradle. I'm leading the build chip project, which is our effort to integrate with Eclipse. And I'm also co-leading the Gradle.com efforts, which is our SaaS-based solution that will come out soon. The focus of today is to give you more insight into the Gradle build and how it relates to the Android build. But before we get started, I'd like to ask you a few words. Who's doing Android development that's listening? Okay, most of the people, I would say 90%. Who's using Android Studio? Okay, maybe I should ask the other way around. Who's not using Android Studio? Okay, there are maybe 5 hands or so. Who has touched the Gradle build? Okay, that's interesting. I would say maybe 2/3. I always ask that question, and it goes up every time I ask. I'm not sure if that's a good sign or not. I think it is. And who's using Gradle outside of an Android project? Java development, Scala. Okay, there are maybe 5 hands that came up. All right. So what is the motivation to talk about Gradle and Android? I mean, it's just a build system, right? I mean, why this big deal of making this choice and not another one, etc. And I want to go into that some more to kind of give you some context. So the Android build is implicitly very complex. If you compare it to just a Java project, the Android build is much more complex. Right, you can also see that on this right-hand side graph that I got from Xavier, the Android lead. It's a simplification of what happens during the Android build, potentially, and it doesn't even include everything. So there's quite some complexity involved. It's more than just compile and you have your classes and you char them up and you're done. Typically, when you do Android development, you're part of a team, and not everybody might do Android stuff on that team. You might also have a backend team. They're doing Java or Scala or etc. So quickly, you have multiple languages. You have Java, Android, and whatnot. So that needs to be part of it as well. Then you have resource generation, and you have extraction of artifacts and conversion to other artifacts, etc. And you have this platform diversity, right? All the fragmentation that you definitely know better than I do, but it's there. So there is quite some complexity involved in dealing with the Android build. And if you look at this complexity on this graph here, expressiveness versus conciseness, you can see that with AND you can be very expressive. You can basically do everything. Those that still know AND, it's very expressive, but it also really grows quickly because you have to do you have to tell it in a lot of detail what to do. On the other hand, you have Maven, which is very concise. It's this XML-based approach. It is concise but not very expressive, right? All of you that have a custom build know how fast you get to the limitations of that. And Gradle kind of combines the two. So it is concise, and I'm going to give an example, but it is also very expressive. So in this example here, this is a fully self-contained Android build. Different product flavors, basically 2 flavor dimensions combined with a build type or 2 build types, and you get a kind of this explosion of cross products. And that leads to a lot of tasks, right? So if you look here, I'm not sure, maybe in the first row you can still read that, I can, but definitely not in the last row. So you end up with like 300 tasks or something. And so what I want to show here is that with a very concise DSL, a lot of things happen behind the scenes. If you wanted to achieve the same with AND, you would have to write a lot more to achieve the same result. And with Maven, I don't know how you would do that. Regarding the languages, so you have multiple languages, I mentioned that. You typically also have multiple teams. And then you want to collaborate on the same software. So you want to have a build system that interacts with that allows you to interact between the different teams. Artifacts are consumed, are produced. And you also want to have these coordinated releases. So and even before the release, if you change something on your backend, you really want to know, does this affect your overall application, which includes an Android part, or not? So you need this coordinated release. And that's really one of the strengths of Gradle, to have like this one big project with sub-projects, and it bundles it up all together. Because in the end, you don't just ship APKs, right? You ship a product. And there's more involved, even beyond building these artifacts. So you want to do automated releases, you want to send release emails, you want to do auto provision of development environments, you might create some documentation with test code in there, or code that has been tested automated or in an automated manner, etc. So there's a lot to it. And just to give you one example, from LinkedIn, which is a big Gradle user. So they have like 2,000 developers, 2,000 components, and they do about 300,000 builds a week, and 1,000 release builds a day. So if you see that scale, I mean, that's probably not the scale of everyone working or in that room right now. But if you're working in such an environment, if you have a very disconnected build, artifacts here and there, and then you kind of somehow put it together, it's not going to scale, right? Okay. So let's take a look at the Android build system. The Android build system is really a beautiful piece of software, in my opinion, because it takes the best of breed of different things. So it uses the Android Studio. IDE is your kind of your user interface based on the IntelliJ platform. You have the Android Gradle plugin, which is then again based on the Gradle platform. And you have the Android tooling. And what we want to look at today really is the Android Gradle plugin and the Gradle platform, and kind of treat them as one, right? Because in the end, I would say you don't care when your build is slow, whether it's the Android plugin or it's the Gradle build. Your build is just slow, right? Or it's fast, but then you don't care neither. Okay. So really what makes it so nice about the Android build system is that there's a single source of truth when it comes to the build logic. So the build is the only place that defines what your build does. There's nothing on top of that in the IDE. So when you open your project, you don't go into your IDE and say, well, I also need this library and that library. No, that's all defined by the build. Okay, it's kind of visionary in that before it hasn't been done, right? Usually you do configuration in your Eclipse, like when you used Eclipse with End before, you had to do everything in Eclipse for Android development. So if you want to define what dependencies you use, you do that in your build. Where are my sources? You do that in the build, but not in the IDE. The IDE will be configured based on your model. Okay, and I want to show that in a bit more detail. So up on the left, you see the Android Studio. That's you, the developer, working in Android Studio. And in the end, since the build is Gradle is the only place that has the build logic, it has to communicate with Gradle to understand what it has to present, what it has to do. And that happens through the tooling API. Does anybody know what the tooling API is, or that it exists? Okay, no one. Okay, that's interesting. So basically, when you have the Android Studio and you have a Gradle build, the way they talk to each other is through a little library called Tooling API. That Tooling API lives in the Android Studio. It's basically on the class path of the IDE. But from there, through inter-process communication, it talks to the Gradle build. And the Gradle build, what I mean by that is really a Gradle daemon. So it's a separate process. So if you want to compile something, the Android Studio will tell the tooling API, compile, and the tooling API will talk to the daemon through inter-process communication and tell that daemon, please compile that build with that task. Right. So that's how it's working. And if you come from the command line, you still interact with Gradle, and usually with the Gradle daemon, if you have it enabled, but you just come in through a different way, which is the launcher. So you don't come in through the tooling API, but through the launcher. Or if you're in a continuous integration server, you also invoke Gradle directly. Okay, but all that just works because Gradle is the single source of truth when it comes to build logic. Right? Everybody queries Gradle, what are my projects? Where is my compile class path? What is my test compile class path, etc. Okay, and just to dig into that a little bit more, the tooling API, which is there in green. So really, as I mentioned, it is a proxy for talking to Gradle, and we will see some of the benefits on the next slide. There is also a mechanism to provide custom models, and that's exactly what happens with Android. So how does Android get all the information it needs from the build, such that it can present it in the IDE or configure the IDE? That is through a custom model. So Android asks Gradle, please give me that model for Android. And then that model comes back and it contains all the information about the variants and the flavors, etc. And then the IDE can consume that and configure the IDE accordingly. If you want to look at it, it's a default Android project. That's the model. Okay, so that's what the Android guys do. They write a model. They provide a plugin for that. That's what you always apply in your script, right? It says apply plugin something Android. That kind of registers that model, and then you can ask for that model through the tooling API. Okay, you see that here. So there's the client VM, that would be the IDE. Has a little jar file, I think it's like 800 Ks or so. And then it asks Gradle to the tooling API, give me that build model or invoke some tasks. So build models you ask for to configure the IDE. Invoking build tasks you do to execute something in the build. Okay, and some of the advantages of that approach is the backward compatibility that we have. So even if your Gradle build used 1.0, you could still talk to it. You might not have all the functionality available, but it's still compatible, right? You have runtime isolation. So let's say Gradle had a memory leak. That wouldn't affect the Android Studio because it's a different process. Or if Android Studio had a memory leak and Gradle would not be affected because it's in a different process. So two sides to look at it. There are some high-level services, so you can cancel a build. That also goes to the tooling API, and whatever it does, it will stop it. It has a continuous mode. I will show that later on. And you can also execute tests. Android Studio is not using that, but I think they will at some point. So we have a specific API that when you run a test, that test is executed by Gradle, which makes sense, right? Because only Gradle knows what is the class path, etc., to run that test. The IDE doesn't really know. It can only do an approximation. And there is an event model. So as you run a build to the tooling API, you get events. Of course, you get all the log output, you get progress, but you also get events like configuration phase starts, stops, execution phase starts, stops, tests have started, tests have finished or failed, etc. All this is consumable through the tooling API. And if you looked at build shape or Gradle integration for Eclipse, you would see that if when you run a build, you see a nice little tree that shows you all these events happening. Okay, and why is all this possible? Because Gradle has a very rich model. And by having a rich model, it knows all these things and it knows what they mean. And then with that information, there's so much you can do, right? If you compare this to an AND build, and I'm not want to say anything against AND, but when you do something with AND itself doesn't know what you're doing, right? It's just very imperative. And so there's no way to write these rich models like they are. It is the case in Gradle. Okay, so regarding performance, of course we all want performance to be lightning fast, and I use this picture because it also uses parallel lightning going from top to bottom, which is one key aspect of performance, right? Doing things in parallel. So what is our goal? Our goal is to minimize the build time, right? To say it in a simple way. And we want to do this using as little memory as needed. And why do we want this? We want quicker feedback about build failures. We want to do more builds per day. We want to do more releases per day. And we want to do more runs on continuous integration. And many more reasons. So there are many reasons why we want to have fast builds. Now, if we observe what happens when you do development, is that from one run to the next one, usually not much changes in your build. Right? You might have this complex build, but what you usually do, you change some source files, you change some tests. Maybe once in a while you remove a resource or you add one, or you add a dependency or change that dependency, but that's already rare, I would say. You don't do this for every build. So between these consecutive test runs, typically not much changes. And if not much changes, not much should have to be worked by the build. Right? So when little changes in the build, little work should be done. And that is something you currently see in the Android plugin. That's not the case. Right? So even if you have a big Android project and you say Gradle task or Gradle help, it will take a while. And that time is proportional to the size of the build. And it shouldn't be, because when you say Gradle help, you're not even executing anything in your build. Right? So does anybody observe that when you do builds that they take longer than you wish them to take? Right. So there's a lot of nodding. And that's really, for the most part, due to the configuration phase. And we'll come to that. Right. So what is the approach at Gradle to improve the performance? And that applies to the Android perspective, but also to all the other ones at Gradle and that are not related to Android. And that's really two approaches. One is the evolutionary one, so you make little improvements here and there. They might have a significant impact, and I'll show that in a graph later on. But there's also the way to say, okay, let's make some revolutionary changes to really make the next step in terms of performance, because you might only do local optimization, but not the global optimization otherwise. Okay, and that's currently happening, and we'll see that. So today, what happens when you build with Gradle? You really have a two-phase build. Is anybody familiar with this, that you have two phases? You have a configuration phase and an execution phase. Okay, so some people seem to be familiar with that. I mean, in the end, you say Gradle build or whatever you call, if you ever go to the command line. But two things will happen. The first one is the configuration phase. That is when your build logic is executed and the build model is built. And in the execution phase, that build model is acted upon, which means the tasks are executed. Right. So we'll look at these two phases, and I'll start with the execution phase because that's the one where more has been done, and then we'll come to the configuration phase. So what are we already doing in terms of optimization during the execution phase? One is the incremental build feature. So if you think of tasks, tasks have inputs and outputs in Gradle, meaning a task consumes certain inputs, like a function, does something with them, and produces an output. Right. And in Gradle, you can annotate or declare what are a task's input and what are the outputs. Right. And with that information, Gradle can do incremental builds, which means if the inputs haven't changed and the outputs have not changed, there is no need to run that task again. So let's say you have a project and you do a compile. It has source files, no compiled files. It will do the compilation. Now you run it again. Does it have to do anything if you didn't change the source file or if you didn't remove the class files? No. Everything is still the same. And by Gradle knowing what the inputs and outputs are, it can do that optimization for you. Right. So that is why when you say Gradle build, if you have a normally configured build, I would say you see it's just up to date, and nothing really has been done, which is good. Because if nothing has changed, nothing should be done, like I said before. So this is just a small example. If you wrote your own task, and the ones from Gradle look very similar, I wrote a task called conversion task, and all it does, it takes a file, it does something with that file, and it creates a new file. Right? It's just a transformation. What it does not matter. That's why I just put a comment there. So that's how you would call it in your Gradle script. You would just say I have a task. It's of this type. My input is one or more files. I'm using just this one, and my target directory where the converted files are written to is this folder. Right. Okay. That's how you would use it. And by using these annotations that you can see up there, the input files and the output directory, you're now telling Gradle what are my inputs and what are my outputs. And Gradle will manage these. It will keep track of them so that when you run it and you run it again, it will remember what were the values the last time you ran it. And if the values are still the same, it will say, oh, this task is up to date, let's skip it. I mean, who has used and has used kind of a timestamp approach to see if no of the timestamps have changed, and then it's not going to do it. Yes, so there's at least one hand. I used to do that a lot too. But I had to do this every time again when I had such a task that was sensitive to inputs and outputs, right? Here it's totally baked into the system. Okay. That's it. That's the conversion task. So just to kind of give you an idea of what this input and output means. And we'll come back to that concept during the configuration phase. That's why I want to show it here first. Okay, there's another, and now this is such a simple concept. You have an input, you have an output, you keep track of it, or Gradle keeps track of it, and then you can do all sorts of things. I just showed you the incremental build feature. Another one is the continuous build feature. So what you can do is, and even with Android you could do that with an Android build, it's not specific to any type of build. Here I'm just saying Gradle W, so that's a Gradle wrapper, or it could be Gradle, doesn't matter. I say test -t. -t stands for continuous mode. And what happens is, as you can see here, it starts the build, it does whatever it needs to do, even if you didn't have the -t. Build successful, whether it did something or not doesn't matter. Total time, but then you don't get back to the command line prompt, but it's saying now waiting for changes. So what's now happening is it is just waiting there. And if you now change something that is an input of the task you invoked, then it would automatically trigger the build and do what's needed. Right? So let's say you write a presentation, and you're using something like, or documentation using something like ASCII doc, and you're always changing the file, running Gradle build, changing the file, running Gradle build. With the continuous mode, you just change your file, and you go to the browser, you say refresh, and it's there. Right? Because as soon as you change the source file and it's detecting the change, it's going to rebuild the artifact, and you're going to see it. Okay, and why? How does it know what to track? I mean, it cannot just track your whole file system. What does it track? Is your inputs. So if your task has defined the inputs, then it knows where to look for changes, and it will just watch these changes if they happen. And if they happen, it knows to trigger a build. Right. So a very powerful feature that is possible based on this very simple concept of declaring inputs and outputs. And that's really key, and you will see that as we go on. As the more you tell Gradle what you're doing and what you have, the more it can do with it, the more smarter things it can do without you having to do them. I mean, you could implement that yourself, like a watch mode. There are even plugins for that, but now it's available to every task that has inputs. Okay. So what have we done in terms of performance improvements, and they're applicable to Android projects as well, incremental builds have been there for a very long time, but if you have a big project, detecting whether something has changed or not took quite some time. So it had to go over all the files, look at the timestamps, do some checksums, etc., just to decide whether everything is up to date or not, or something is out of date or not. And it is especially painful when you have a big project and nothing has changed, because what it will do is it will go through your 400,000 files just to realize, oh, nothing has changed. Okay, and that takes time. So in just the latest release that is RC1 is out now, there has been some improvements to the management of these file checksums, such that if you have a very large project, you will see that if you have almost no changes, that will be much faster to detect. If you have a small project, you will also notice a difference, but it's just not as spectacular as the project is when it is very big. Okay. And that brings us back to what I said before, and I'm going to say it again, is if little has changed, little should happen. There's also fast compilation for continuous mode. So let's say you're using that continuous mode, you're making changes, it's always building as things are changing. If you are compiling as part of this change that happens, Gradle will spawn a compiler daemon by default, at least for Java. And the other ones you can configure it to use a compiler daemon. Now, what happens with continuous builds now is that this daemon will stay alive even as the build runs. So as long as the build session of a continuous build runs, the compiler daemon will be there. And of course, everything that's already there is much faster to use than if it has to start up, it has to warm up, etc. Okay, so these are all evolutionary improvements. Right. Okay, let's look at the configuration phase. there, if you look at your build scripts, it is, even though in Android it is declarative, as soon as you do your own stuff, it becomes quickly quite imperative. And even if you don't write any imperative code, what happens behind the scene by the Android plugin is quite imperative. So you might have a DSL that's declarative, but what Android has to do is then very imperative. And as soon as it gets imperative in your code or in the plugin's code, Gradle doesn't know what you're doing. And if it doesn't know what you're doing, it cannot optimize things. So what do people do? They do things lazily because it shouldn't happen too early, or they use lazy collections, so they detect all the changes that come later, or they use the project after evaluate, which is a hook where it allows you to say, okay, now the configuration phase is finished, now let me do something. But what if multiple people add such a hook? Who's going to be called first? Who's going to be called last? Right. So there's a lot of trickery going on to make this work in a kind of a complex setup like the Android build, which is very complex. If you think of like build flavors, Android has to know, okay, are you done declaring your build flavors? And until that's the case, it cannot really do anything. But it doesn't know when you're done, right? So it has to do these late hooks that don't sort of work. What you end up with is a declarative build model. So that's kind of the output of the configuration phase. This is declarative. You have your model. But the problem is Gradle doesn't really know how that model came together. It just knows, okay, now it's here. And next time you run a build, it has no knowledge how it happened, so it has to do everything again. Okay. And another problem you see here, it's building the whole model, even though it will only build some things. That's what I said or described with Gradle help. It will build the whole model. It will know every variant and whatever you want to. But all you really want to do is call Gradle help. So how much time was invested to what you wanted to do is not in the correct relation. Right. So of course I'm pointing this all out because there's a solution for that. Otherwise, that would not be good. Right. Yes, as I mentioned, so for Android, at construction time or at the configuration time, the whole model is built. And if you have a big project, let's say 400 project, sub-project build and 10 variants, it's huge, right? That's why things take so long. And I think at the Android team, they have a build that takes more like two minutes to just call like Gradle tasks, right? Because it has to build so many things, which takes time. The other thing is that it has to do the full dependency resolution and the processing at evaluation time, right, or configuration time. And as I mentioned before, it doesn't really know all the flavors you want to have until very late, but then it's so late that it had to do a lot of stuff. So what has been done until today to improve the configuration phase? So the build scripts, they compile faster, so a lot of caching happens there in a reliable way. And as we use new versions of Groovy to do the parsing of the DSL, it gets faster kind of out of the box. Right. So Gradle is not written in Groovy. That's if people think that, it's not true. But the DSL layer is done with Groovy. There's another feature called Configure on Demand. Maybe one or the other has already used this. It allows you to say, when you run some tasks, only configure those projects that are reached by those tasks. But it's only working under certain conditions. And if you violate these conditions, the output is not kind of guaranteed. Right? But if you have a kind of, I'd say, a clean project that doesn't try to poke into other projects of the same build, then using Configure on Demand works really well. Which means it will not go through these projects that are not kind of reachable from the tasks you want to run. So let's say you have a project, you run build, and you have a compile dependency on another project. It will also configure that other project. But if a third project is not kind of reached that way, it will not configure it, which can save you a lot of time. Again, these improvements are evolutionary. Okay. So let's look at the Android build. So this is a graph, and so to set the stage here, so the Android team and the Gradle team have a really good relationship, and it's a really a mutual it's a mutual benefit that comes out of this relationship. So if I'm pointing out some stuff that concerns the Android side, it's not finger pointing at all. It's really working on the solutions together. So if you do a clean install, you will see that a lot of time in this example is used for the pre-dexing. So all your libraries that you're consuming, external dependencies, they have to be dexed as well. And that takes a significant amount of time in this build. You will see it says clean install. Usually they shouldn't be uppercase, but it doesn't matter. Once you do this and you run the build again, they are cached. So it only happens once. But still, that can hurt the first time you do it if you have a lot of dependencies. Right. Okay. So there's quite some potential for optimizations there for the pre-dexing. And one is really that we want to have a clean, safe cache. But it's a generic cache, which means if you have dependencies and they need to be transformed before they are consumed, that should become part of Gradle, and then it can be used for the Android plugins as well. Right. The other one is parallelization. This pre-dexing could happen in parallel, but it's currently not happening in parallel. So this is again something that Gradle could support and will support, that this pre-dexing can happen in parallel. And the third one is really a distributed cache that will come, that's already on the roadmap, without a date though. And what this means is, let's imagine you're a team and you have a distributed cache that lives somewhere. Then the first person you doing the build will have to will trigger the dexing or the pre-dexing of these libraries, but then all other developers that will also call the build and it requires the pre-dexing will first check the cache if it's already there. And if it's there, it will already be consumed. So this kind of reduces the time for pre-dexing on your local machine to 0. So that is another aspect. And of course, before going to the distributed cache, it will check locally if something's already there. And if it's not there, go to the distributed cache. If it's there, use it from there, download it, store it. It's almost like consuming a dependency, an external dependency. Right. And then there's the dexing, which you can see on this graph. Which again takes a significant amount of time, and there is not much Gradle can do. This is really more in the hands of the Android team, but they're working on a new implementation, as I understand, this Jack, which for one can do faster dexing, and the other one is it can do incremental dexing. That's currently not happening, so you change one file, it has to dex everything again. Okay. Okay, so that's kind of the current state. What has been already optimized to this point is kind of evolutionary changes, still some limitations. Android is affected, all the other builds are affected as well. And now let's look at what's coming. And really the bottleneck that we're focusing on right now is the configuration phase. What I said, everything is kind of built into a build model that is then consumed, even if nothing needs to be consumed of that build model. You're just calling Gradle help. And that's called just a new configuration model. And this is really revolutionary. It's not just tweaking little bits here and there. It's really just something that we build up in parallel, also have some bridging to make the old world work with the new world. And so really, from what I said before, having all things available but only needing some things, we will go to only knowing those things that we need for building. Right. So this new configuration model, I will give some code examples. Really, it comes back to what I just explained about the execution phase. Is for one, we want to know about the inputs and the outputs, because if you know the inputs and outputs, you can start. You know in what order to do things. You can start doing things in parallel because you know you can build up a graph. And if you have a graph, you can take the trees, the subtrees, and you can build them in parallel. There's so much you can do once you know this. So what has already been done for execution phase will happen for the configuration phase now as well. And the key aspect that will change is that you will describe your model. It will be very declarative. You say, what should my model be? And then Gradle will derive the implementation. So it will manage the model. Right? And by managing it, Gradle can be smart about it in what it does with it. So what it will allow you to do is richer modeling. You can already see this in the Android build. They did an awesome job of how you model a build. If you apply the plugin and you have this Android extension, all the things you do in a declarative way, and so much magic happens behind the scene. It's really great, especially given those constraints that I listed before. So Android will really benefit from that because they can get rid of all the trickery. It will be cleaner modeling because right now, if you look at the tasks, you would see that there is execution logic as well as configuration logic in there. And so that will be a clean separation, a task, or it will not be called a task anymore, but you have your managed types and all they contain is data. There's nothing on there about execution. You can collaborate better. So I said that things have to be, you don't know when things are ready, so you have to do them very late. So that will go away as well. It will be really easy to say, okay, I'm the one creating it. Another one wants to say, I want to add some defaults. The third one says, I want to mutate it. And the fourth one says, I want to do something at the end. And another one yet says, I want to do some validation. Okay, so much more deterministic as well. And comprehensible. So by having a model, again, like for the execution where we have a task and a task graph, if there is a model for your build and you know where things came from, you can do really interesting reports and you know why things are happening because you know who contributed what. Okay, so let's look at the code example. So we have this managed type here called picture, and all it is an interface. Right? Gradle will provide the implementation. It will provide the implementation such that it knows if somebody sets the name. Because if it knows who sets the name, it's something it can report on. And it also knows I can derive other things from that as well. Another advantage of these managed types is that they can be persisted. So as it goes and builds that model, if there are certain things it doesn't need, it can write them to disk, load them again later. Or it can store them in the daemon, and when you run the next build, it can reuse them. It can cache things. So that's why they are externalizable. Okay, so this is an example. If has anybody written a Gradle plugin yet? Okay. Cool. So we have one person that has written a Gradle plugin. This changed a little bit. So now it looks like this, and you see this is very declarative. You basically say, I want to. There's a model for creating a picture, and there's a way to mutate the picture. So the picture is passed in, and you can set these arguments. And when you set them, because the implementation of picture is controlled by Gradle, again, it can track. It knows who did these changes. Okay. And there's a lot more to it, but I just want to give you kind of a little overview here. And then the last part is really providing a DSL, and that's what you as a developer of an Android application are most interested in, is that you want to declare what to do. And that will be something like here. So based on the example I just showed you, so you say, okay, here's my model, here's a picture, I want to create a new picture instance or picture node, and I want to set the name to something, and I want to set the tags to something. Right. This looks very similar to how you do it in the Android plugin right now, but the difference is that the implementation of all this is controlled by Gradle, and by knowing all this, it can do all the optimizations I mentioned. Okay, so to give you an example on this as well, so we have a report here, exactly for that example I showed, and you can see here that this create picture, you can see what the type is, you can see who created it, and you can also see what were the rules that were applied on that picture. So the configure was called after the creation. Right. And you can see that for every attribute, who created it, what's the value, what's the type. Okay. And so with all this rich information, there's a lot of smartness that can happen. Now, if you take the latest Android plugin, it ships really with two plugins, an old version and a new version. And the underlying logic of what to do during the build is the same, but the way it's configured is different. One is using the new model, the other one is using the old model. So here you can see that you have to use this model outmost keyword, and then within you say Android, and then it's very similar. It's not complete yet, it's really work in progress, but every time a new Gradle release comes out, they make use of the latest features and adjust their experimental plugin. And at some point, this plugin will become the default plugin, right? So you see there's some not so nice things right now that you have to use the dot notation here again, and you have to say create. If it's a new one, you can use just the name. If it's an existing one, that will go away. Sure, okay. But I hope this gets you excited that you see Gradle makes these changes. A lot of them are driven from Android, but they fit into the big vision of Gradle. And Android consumes them release by release, making their plugin better. Okay, so what do we get from doing all this? The configuration will become parallelizable, just like the task execution can be parallelizable. Managed types can be externalized, which is important when it comes to caching. And the model can be reused across invocations because Gradle knows the inputs and the outputs for the configuration phase as well. And so it knows if you can reuse something or not. Right? It knows everything basically, and by doing this, it can do the minimum that's required to do. And that's really a revolutionary change. It's a huge undertaking because we don't want to break what's there. So everything happens in parallel to what's there, and there's bridging from the old world to the new, like I mentioned before. And so that takes some effort. So it will not be a big bang, right? It's already used today. If you soon with the new Android plugin, the C++ support that it has for building the NDKs will already use the Gradle plugin for C++, and that is already based on this new configuration model, right? So they're really sticking to it. Okay, so if we look at the roadmap for the next 6 to 12 months, without any guarantees, of course, this improvement is very high on the list. These improvements, right? Because Android is a very important ecosystem for Gradle, but also the other ecosystems want to have better performance. I mean, everybody wants always better performance. So there's a lot of investment going on there. And the other one is it's auto correction. It should say generify dependency management. So really, there's not only dependencies between libraries. You can also see dependencies between much higher level constructs. And that's currently happening as well. So I'm not going to go into that, but I want to go into performance just a little bit. So how we proceed is usually we have these hotspots that we try to identify. And once we fix them, the next one will show up. I mean, everybody that has done performance profiling knows how that works. Caching and reusing is really a key aspect too. So reuse what's already there rather than rebuilding it. Doing work in parallel. That's huge. And in parallel means for one on the same machine, but it can also mean across machines. So distributed builds is something that will come as well. So you have a build, you do different things, you need to configure things. That can happen in parallel. It can even happen across machines. And doing work in the background. And the continuous mode that I showed is one example of that. So you do your work, and while you do your work, Gradle can already see if something has changed, and if it has changed, it can already prepare it such that when you do want to run it, it's already there. Right. And all these things that I just mentioned, these techniques on the left-hand side, can be applied to many things on the right-hand side. And the current ones focused on is the build configuration. That's what I just explained. The next one will be dependency resolution. So a lot of things can happen in parallel there too. Caching already happens, but more can happen. And task execution. A lot has been done here already, but more can be done. So let's imagine your tasks are fully managed by Gradle, which will be the case with the new configuration model. Then you can run these tasks in parallel, right? And once you can run them in parallel, I mean, and Gradle knows what can be run in parallel. It's a huge step forward. You can already enable that to some extent, but it's not super deterministic because Gradle doesn't really know what your tasks do. Okay. So if we look at the performance, this is just some tests we ran. If you use this new approach, totally based on these managed types, this is not an Android build, but still, even with Gradle builds, you can have variants. The concept of variants came out of the Android requirements, but it's a concept that applies in general. Like even a variant could be building against JDK 6 or 7 or 8. These are 3 different variants. So if you see here, if you build one variant with this totally managed model, it basically takes 0 time. If you build one project, yeah, it takes some time. If you build all, it takes more time. But the key here is the less you do, or the less you want to do, the less Gradle has to do. That's the thing. Of course, if you want to do a full build, the new model is not going to give you that much. can give you some, but it's not great, or not very significant. But the less you do, the less Gradle will do, which is to your benefit, right? And I think that's well visible here with this curve. Okay. And just to round this off, because this is important to the context of Android as well, dependency management. So there is dependency management, and you can have your dependencies on the variants, but we want to go further, and that is when you consume external libraries, you want to consume the right variant. So let's say you create a library in variant ABC, and now you have another project that consumes this library, and it also has variants ABC. You want to consume the right variant of that external dependency. Same for native libraries. You also want to consume the right one. If you're on the debug build type, you want to use everything basically in debug, right? And that will be possible by storing this extra metadata with these variants, and then when it comes to resolution, it will try to pick the right variant. If it finds one, it uses it. If it doesn't, it will blow up. Right. Same will happen in the Java space. So if you say I'm building a library for JDK8, and you're depending on another library, if that library says I'm only available, or I'm a variant only for JDK9 and later, well, it cannot use it. Right. So this will be really full variant-aware dependency management. I will come to. Okay, so just to round this off, we're also working on Gradle.com. And this will be, for us, we see Android as a really interesting target for that. So as you run your build, you can upload like a build receipt to Gradle.com, and you can share this with people you want to share it. So let's say you have a build master in your team, you have a local problem, you can upload that, and your build master can look at it, and based on what he sees, he can figure out what's the problem, what has changed. Other things are you build, it's all good, and then suddenly the build stops working. Well, what happened? Maybe, okay, then you realize, oh, a transitive dependency has changed. All these things will help you detect. So it will show you what's going on. It will also help you detect errors and propose solutions. So that's currently what's going on with Gradle.com. So let's say you want to go to the forum. You had some problems building. You can just attach a link to the build receipt, and then somebody can go on it and say, okay, look, I see a problem here. Somebody else had that problem too. There's a link to the forum, etc. So that's coming very soon. It's in full development right now. And again, we're making progress there. Also, I'm not sure if anybody knows, there's a Udacity class on Gradle and Android development. So this has been done together with Google. It's an awesome class. I think it looks like almost 10,000 people have already signed up for this. So it's a good way to learn Gradle in the context of Android. All right. So, yep. Gradle is a great company to work at, and there are always more people needed. And that brings me to the end of this presentation.
Okay, thank you very much, Etienne. There hasn't been any questions online, but I don't know if anybody has a live question right now. Nope, but I think that's actually pretty good because time is up. So thank you again very much, and remember to provide feedback for Etienne.
Thank you.